Hi, in this video I want to show you how to do a very simple multilinear regression in Python. And the way that we need to do it, there are three steps. The first is that we need to get some data. The second one is that we need to isolate the dependent and the independent variables. And then the last step is to then perform our linear regression and then visualize the results. Let's start with the first one, import libraries, and we need to import the stats models API and .api as sm. And this is a library that first enables us to get some data, and then second enables us to do the linear regression. The next step is to then import the dataset, and we'll call it dataset equals to, we use our sm that we have just imported or that we will import, use .datasets for the module, and then use the function get r dataset. Overall, r is far more abundant in datasets, and this function really enables us to get or to take advantage of that. And then the first thing is the name of the package, which for us is murder rates. And then the other step is the package. So package equals, and then again in quotes, AER, and then we just do .data. And let's select everything and click on F9, and then it will eventually appear in our variable explorer. In the meanwhile, I want us to isolate the x and y, or the independent and the dependent variables x and y equals, and then I would have to use dataset, and it is ready already. So let's have a look. So this is the rate, so this is our dependent variable. Then we have the conviction, executions, time, income, and then non-Caucasian, for instance. And what I would like to highlight is that what you can feed to a linear regression in Python can only be numerical. So this southern, you'd have to transform it in a way that it can be used in your regression, for instance, into its binary format. Hence, what we want to do is that we want to isolate the y, and we want to take the first column, and then the x, we want to take the second, all up until the second to last. And this is exactly what we're going to do. So for the y, it is super simple. So dataset.ilog open square brackets, then colon, because we want all the observations, then a comma, and then we state 0, because in Python index starts at 0. So our first column as index 0, and that is the one we state. And let's do F9 to run to see we have our y, which is our rate, and now it is the x. So x equals, and then we do dataset again, .ilog open square brackets. We do the colon because we want all the observations, comma, and then we do starting from 1, so from the second column, all up until the last one. But on the right, or the last one, is always excluded from the index. Hence, this would choose all up until the second to last. Let's click on F9 to run, and then we'd see here our X with 6 columns, and the southern is not there. Next step is to then do the regression. So here we go. And to do this, first of all, we need to add a constant, and this constant would then be replaced by the intercept when we are doing the regression. So sm, and then add underscore constant, and then to x. There you go. This is more of a bureaucratic step. And now, yes, we can create our model, and then we do sm.ols, and then inside we include our y and then our x. And then very simply we do dot fit, and we open the parentheses and you click on F9. So our model was created. And then to have a look at the results, so model.summary, open the parentheses and then click on F9. It says here that we have a multicollinearity issue, very likely, since we only have 44 variables. So it is very likely that there's always some kind of issue when you have so few observations. But what I would like to highlight is the coefficients overall. So this is where you get the impact, and of course, positive as a positive impact on the murder rates, negative as a negative impact on the murder rates. Then you also have the p-value, and take in consideration that everything above 0.1 is likely to have not an impact on your dependent variable. And then you have the interval of confidence. Then, of course, you can have a look as well at the adjusted R-square, so 65.5, so we're able to explain roughly 66% of the variance of our dependent variable. So this is for the very basics on linear regression or multilinear regression. I have a course on Udemy that if you want to really dive deep into this, I would really encourage you to do so. If you enjoyed the video as well, please do subscribe to the channel and put a thumbs up. I'm looking forward to seeing you in another video or on Udemy. And until then, have fun.